Hello. This is going to be we're going to continue on the IBU practice exam uh practice test mode 3. My internet went off, so it just turned off, so that's why oops. I have to do this in two parts. Okay, let's continue off. We stopped off on uh question 12, right? Okay. Mm, Okay. So question 12, we have this equation and there's only two sides. Sorry, my writing tablet. Yes, you can cross multiply. That's what I would do. If you only have two sides, I'd cross multiply. So but before I cross multiply, to make your life easier, I'm going to simplify the denominator. Okay, so let's do that. This one we have 6 over 2z plus 3. There's nothing more you can do on the denominator, right? What about on the right? Let's see, you have a 9. And then on the bottom, you have a 3z and a 1z. Is there anything yes, you can neglect these 3z and the 1z, which is 4z plus 2. Okay. Now you may cross multiply. So it's going to be 6 times 4z plus 2 equals to 9 times 2z plus 3. Okay. Multiply, FOIL this out. 6 times 4z is 24z. 6 times 2 is 12. 9 times 2z is 18z, and 9 times 3 is 27. And then solve for z, so I'm going to subtract 18. I mean, get all the z's on the side. 27, and 24 minus 18. 6z is 12. Subtract 12. Subtract 12 on both sides. And then we get 27 minus 12, which is 15. And then solve for z by dividing both sides by 6. And you get 15/6. Oh, but if you look at all the choices, they're all mixed, right? See how you have a fraction that's mixed. We can make 15/6 mix out because it's improper. You just do the dots. And how many times is 6 going to 15? About twice. So 6 times 2 is 12. 15 minus 12 is 3. Run down the so this is how you make a mix. So it's gonna be 2, and then your remainder is 3. And then divided by whatever you're dividing, which is 6. And then 3/6 can be reduced by 3, so that's going to be 2.5. So z is 2.5. Let's move on to question 13. Evaluate the expression x squared minus 15x plus 56, and where x equals 11. So all you got to do is literally plug in at wherever you see x, plug in 11. That's all you got to do. So you don't even have to FOIL it out if you don't want to. So wherever you see x, replace it with 11. So it's going to be 11 squared minus 15 times 11 plus 56. So 11 squared is going to be 121. Negative 15 times 11 is negative 165 plus 56. And because you can't do a calculator, what I would do is add the 121 plus 56. I think that's easier. 121 plus 56 is 177. Then just subtract 177 from 165. Without a calculator, so 7 minus 5 is 2. 7 minus 6 is 1. You get 12. If p equals, okay, so 14, if p equals 60, r equals 6, t equals 8, what is a equals r minus p all over t? So if you don't like the slanted line, you can rewrite it as horizontal. If it makes it easier, so you can rewrite this as a equals r minus p all over t. So r is 6 minus p is 60 all over t, just means. And then 6 minus 60 is negative 54 divided by 8. And if you look at our choices on it's decimals, so we got to simplify this. Well, you can eliminate a because our value should be negative. So it's either B or C. What do you think? So I think you can figure out it's C because you can't 54 over 8 doesn't come out nicely. So you're gonna have some decimals. So if you want to do the long way, this is going to be how many times is 8 going to 54? About 6. 8 times 6 is 48. 54 minus 48 is 6. Decimal, bring down the 0. How many times does 8 go to 60? 7. 8 times 7 is 56. 60 minus 56 is 4. Bring down the 0, that would be 5. Okay, 15, isolate G. So we have big F equals GMN. Better figure out what big G is. So what I would do is just cross multiply, right? This has this F has an invisible one, so cross multiply. 1 times GMN is going to be GMN, right? And then big F times R is going to be big F times small r. So what is big G? Just get rid of this MN, so divide both sides by MN, and you get G equals to big F R all over MN. Okay, what is that going to be? It's B, right? They see how R and F, you can switch those, it's the same thing with FR because of the commutative property, and then MN, yes, so it's definitely B. Okay, 16, factor the polynomial. So the technique is called simple factoring because the A values. So you're going to write out your two parentheses. You're going to put an X here, an X there, because when you FOIL it out, you want an X square, right? And then put a little blank space. Right. put a little blank space, and then this is where it can get tricky. Can you think of two numbers that are multiplied 24 and when added gives you -14? So think of two numbers that multiply positive 24, and then with the same two numbers, and when added gives you -14. Uh, I think it's going to be 12 and 2. And because I want positive 24, I think I'll use -12 too. Let's see if this works. So -12 times -2 is positive 24. -12 plus -2 is -14. They both work. So we'll definitely do -12 with -2. You could switch the order, right? But this is your answer. Okay, it says as factor do not solve, so that's why it's in all parentheses. Okay, let's move on to 17. Simplify the polynomials. Yes. What you're going to do is you're just going to have to FOIL it out and collect like terms. So what I will do is FOIL out this part first. This, as you can see, this x squared is not near the parentheses, so you're going to just bring that down once you're done FOILing. Okay. So what is -3x times 5? -15x. What is -3x times -x? Positive 3x squared. What is 2 times 5 is 10. And then what is 2 times -x, which is -2x. Kind of, let's clean this up. So it's going to be 3x squared. -15x and -2x is -17x. And then you have this plus 10. Okay. Then bring down this x squared because it's not near, so just bring it down. And it's all about collecting like terms. So you can add 3x and then 1x squared. That's going to be 4x squared. Then you have this -17x. You have this plus 10. That's all you can do. So that's it. X squared. Letter B. Consider the formula. Which of the following is equivalent to these ones? So it's just like the other one. We got to FOIL it out and then simplify it left like terms. So what I would do, see this x, what I would do first is FOIL this out, clean it up, clean it up, and then distribute that x. So let's do that first. So FOIL out x plus 8 times 3x squared plus 1. So FOIL this out, this is going to be x squared times 3x squared is 3x cubed. X squared times 1 is positive x. 8 times 3x squared is 24x squared. And then 8 times 1 is 8. Okay, so this is going to be 3x, clean it up a bit, 3x cubed plus 24x squared. And we have 1x plus 8. And then we're going to times that by x. So this is going to be 3 x4 plus 24 x cubed plus x squared plus 8x. Okay. This one, consider the following formula. We have 2 over 5 equals s over 3 plus 2. And which of the following statement is true for this one? Okay, so this is one of those ones where you have to graph. This is related to a linear equation. And it's best to graph this one on a Cartesian plane. Sometimes in these linear problems, sometimes it's best to just plug in values. Sometimes it's best to graph it on a Cartesian plane and figure out which one of the are the true statement. So what I'm going to do is first, and this is how I know it's a linear equation. First, I'm going to rewrite it. I don't like vertical, like slanted. I like it for completely horizontal. So I'm going to rewrite this as t horizontal 5 as over 3 plus 2. And I know then what I'm going to do is get rid of the fraction by multiplying all 3 sides of that bus. Right? So if you look at our bottom, we have a 5, a 3, and a 1. They're all in the premise form, and they're all at different bases. So if that's the case, it's just a mixture of all the b. So your LCD is 5 times 3 times 1. Okay. We'll go ahead and FOIL out this 15. So what's 15 times 2 over 5? Well, I know that 15 divided by 5 is 3, so it's 3t. And then what's 15 times s over 3? 15 divided by 3 is 5s. And then 15 times 2 is 13. Okay, then what I would do is get t by itself. So I'm going to divide everything by 3. So you get t equals to 5 third s. And then 13 divided by 3 is 10. Okay, this is how I know it's a linear equation, because it is in the form of y equals mx plus b. The only difference is our y is not y, our y is t, our x is not x, our x is s, right? So that's the next thing we need to know. You need to know your axis. So my t is really like your y, because we're going to graph it on a Cartesian plane. And you need to, yeah. And my s is really like my x. Okay. So how am I going to graph this? I'm going to graph it by finding the y-intercept and the x-intercept. So the y-intercept is already given. The y-intercept is your b, which is 10. So my y-intercept coordinate can be expressed as 0. What about my x-intercept? So my x is my x-intercept. Yes. How do you find the x-intercept? You simply set y to 0. So if you recall, our y is our t, so it's going to be 0 equals 5 third s plus 10. 5 third s is 10. And then let's get rid of the fraction by multiplying everything by the LCD, which I believe is 3. 3 times 0 is 0. 3 times 5 thirds is 5s. And then 10 times 3 is 30. And if you subtract, solve for s with 5 thirds on both sides, you get it. Negative 30 equals to 5s. And that's divided by 5. S equals -30 divided by 5 is -6. So my x-intercept is -6.0. Okay. So now we can graph it on a Cartesian plane. How would it look like on a Cartesian plane? No. Oops. But you can call our x is really s, and our y is really t. So we have an x-intercept at -6. So we have an x-intercept at -6, right here. And then do we have a y-intercept? Yes. So let's pretend this is 10. Okay. So if you connect the dots, as you can see, you have a linear line. So now let's look at each choice. So question A, if s is less than -3, t is positive. So locate where -3 on the s is. So here's 1, 2, here's -3. So is this true? I think it's partially true. So if you go to negative anything number than less than -3, so -4, right? Yes, the t. So at -4, the t is positive, and then but the thing is, if you keep on going, like for example, -7, your t is now going to be negative. So it's not always true. So that's why it's not A. Okay, let's try B. If s is less than -6, so here's -6, is t positive? No, that's actually false. So if you look at a graph, let's pretend, let's use -7, because -7 is less than -6. Is t -7 will give you a negative t value right here. So that's completely false. Let's try C. C says if s is less than -3, here's -3, so maybe we can use -4. T is negative. Not that's not always true. So here's a number less than -3. So let's try -4. Yes, the t is positive. But if you go smaller than -3, so it doesn't, for example, -7, um, it's negative. So that's why it's not. What about D, the last one? D says if S is greater than, so that means we can use -2. T is positive. Yes, I think that's always going to be true. So if you do -2, positive. If you use -1, the T is positive. If you use 0, it's 10. If you use 1, it's like higher, 11, etc. So I think this is always going to be true. Okay. So I'm not gonna lie, these kind of problems where you have to graph it on a Cartesian plane or these are always the difficult ones. Okay. And like I said before, sometimes you can get away with it without graphing it. Sometimes you just have to graph it. So you have to know how to graph it. Okay. Question 20. Consider the following formula x equals 1 over y, which of the following is true. So this is this a linear line? It is. But should we graph it? I don't think, no. Oh, I know why. We can't graph it. Um, I think you can only graph because this is not a linear line, right? We can't graph it. This is not a linear. This is how I know it. It's going to be x equals 1 over y. And if you cross multiply, right, if you try to get y by itself, you're going to get yx equals to 1. And then if you try to get y by itself by dividing those out by x, you get y equal to minus x, right? This is not a linear line. This is a rational thing because it's in a fraction, right? So no, we can't graph it. So what we'll do is just try plugging values. So let's look at each. So we have x equals 1 over y, right? When x is positive, y is 1. So what you can use any x value you like. Any positive. So that includes 0. Or you can use 1. You can use 2. Let's try 0. So if x is 0, because that's technically positive, the y must be greater. Let's see. So it's going to be 0 equals 1 over y. And then this can't work. 0 times y is 0. That's null. And then, so this isn't true, right? When x is positive, y is always greater than 1. So what if x was 0, which is technically positive? This gives me a false statement, so it's not a. What about b? When x is positive, y is negative. So that's not always true. Like we tried 0, x is technically 0, and give an undefined term. So we can't do that one either. What about c? When x is negative. So let's plug in some negative x value. So let's try x equals negative. We can't use 0 because 0 is still positive. So let's try it. X is negative 1, and then we have 1 over y. And you want to solve for y. This is going to be y times negative 1 is negative y plus 1, and then get y by itself back to y by itself by negative 1. You get y equals negative 1. This is true when x is negative. Y is positive. Nope, we just proved that y is negative. What about the last? I think it has to be the last one. And when x is negative, so when we try negative 1, y is negative. Yes, that is the only true statement. And so this one I couldn't graph it because it wasn't a linear. So I just plugged in values and figure out which one is the correct choice. Okay, 21. Consider the function q equals 1 over 2. So I don't like horizontal. I'm just going to write it as q equals to 1 over 2. So this is definitely a linear. You can also say, see how the R is on the top? You could put R on the top or the center, but never on the bottom, because if it's in the bottom, it's irrational. So you can also rewrite this as one half R where the R is in the center, right? So this is a linear line, and I know it's because it's in the form of y equals mx plus b. The only difference is our b is, we don't have a b, our b is 0, so that means it goes with the origin. So what I'm going to do is graph it. So I got to figure out what is my x, my y. So our x is really our r, and my y is really the q. Okay, that's also very important. So our x is really our r, and our y is really like our q. And we have 1 point, the origin, because we don't have a b. Um, what is our y-intercept? So how do you find y-intercept? We set x to 0, so our q is our x. Um, yeah, this isn't gonna work out. So what I'm gonna do is just graph it using the rise over run method. So we know that my slope is positive 1/2. So this is how you would graph it. Right, so you start at the origin, and then our slope is positive 1/2. So what that means is go from 1 to the right, and also go down 1 and then 2 to the left, right? And the dots, and you get this. Okay, so what we're gonna do is now we have our graph. Let's figure it out. So is it A, the difference between the values of R and Q diminishes for greater positive values of Q? I don't think so. I don't think so. The difference between the values of R and Q diminishes for greater positive values of Q. I don't think that's true. What about B? The difference between the values of R and Q is constant. I know that's a false. And this is why I they're saying that there's yeah, this is all false because if you pick some points, this graph, so if I use 0, 0, and then this one is like 2, comma 1, and then our x is really r, and then our y's are really our q. They're not obviously they're not the same, they're not constant, right? We went from 0, 0 to 2 to 1. It's not constant, but I don't think it's me. What about C? For the positive values, the difference between Q and Z is less than the difference between R and Z. Yes. So I just realized this one, you didn't have to graph it. Here, I'll show you. The answer is C. So the reason why here, we could have got away with this without graphing, even though it's a linear line. So they're saying that Q equals R2, right? What I would do is solve for R, right? So over here, if I want to solve for R, I'm gonna have to cross multiply. Let's give me R equals 2Q. And what I'll do is I guess I'm going to so then I'm going to use this equation. So it's going to be Q equals R over 2, and then I'm going to replace my R with 2Q, and then divide this by 2. And 2's cancel, so you're left with Q. So this is a true statement, which just proves that C is correct. For positive values, the difference between Q is and 0 is less than the difference between R and Q. R and 0. Yeah, it's definitely C. Let's do 22. Consider the following formula. You have 2e plus 3d plus equals to 4de minus 3d. If e equals a positive c, which of the following is true for this formula? So all you gotta do is substitute e for 2. That's it. Let's do that. We have 2 times e, which is 2, plus bd. Or d. Oh, you can replace this e with 2, so it's 4d. And then replace e with 2 minus 3d. This is going to be 8d minus 3d. 8d minus 3d is 5d. And then on the left side, 2 times 2 is 4 plus 3d. And then go ahead and solve for d. Uh, so I'm going to subtract 3d. You get 4 equals 5 minus 2d. Divide this by 2. You get 4 divided by 2. And yes, it's letter B because D equals to E, right? D is 2, E is 2. There we go. Consider the following formula: y equals 5 minus 2d, which of the following is true? A 23 is definitely a linear equation, right? And I think this one, I think this one is best to graph it on a Cartesian plane. I don't think it's best to just plug in value, because sometimes when you plug in values, it could be partially true, so I'm not really sure. So what first I'm going to do is rewrite this as y equals, I'm going to put the letter first, so I'm going to say like with maybe 2w is 5, right? And what's our x and our y? So our x is rho w and our y is rho y, right? And then now we know that, then what we got to do is figure out our y-intercept and my x-intercept. So my y-intercept is 0, 5, right? It's basically the speed value. My x-intercept, we set y to 0, so it's going to be 0 equals to negative 2w plus 5, and then solve for w, so I'm going to subtract 5, you get negative 5, so negative 2w, and then divide this by 2, and you could easily do this. Negative 5 divided by negative 2 is positive 2.5. Okay, so we have an x-intercept at 2.5, 0. Okay, once you have your x and y-intercept, you're ready to graph. So we said that our x is really, what's our x? W, and our y is really y. And we have an x-intercept at 2.5. And we have a y-intercept at 0.5. My x-intercept is 2.5, there's 2, there's 3, 2.5 is one in the middle. Connect the dots. Just try to get both straighter. Mine's is interest rate, but you get the idea. Now let's test each one if let's test each one to see if which is the correct one. So letter A, if W is less than 10, Y is positive. This is true. So locate where W is right here. W is less than 10. So that means like 9. Let's pretend this is 9. The Y value is positive. That's false. Because at 9, our YW is negative. So that's not true. What about B? If W is greater than negative 2.5, so locate where negative 2.5 on the W axis or the X axis. Here's -2, here's -3, -2.5 is right here. I believe so at -2.5, it looks like our y has to be positive. So that's false. C. So C is if W is greater than -2.5, so here locate -2.5, y is 5. So that's partially true, but not always true. Anything larger than -2.5 is this. So at -2.5, yes, the y value is positive. -2, the y is positive. At -1, the y is positive. At 0, it's 5. And then at 1, it's still positive. But if anything, like for example, 4, it starts to get negative. So that's not always true. So it's not A, B, or C. Let's try D. If W is less than 2.5, so locatable 2.5 is right here, less than. So we like 2.4, 2.3, or even 2. It starts to get negative, like at 2. Yeah, if W is less than 2, positive 2.5. So at 2, like even 2.4, it starts to get negative. At 2, it's definitely negative. Wait, no, sorry. Whoops, I looked at, no, it's positive, not negative. I was looking at the, yeah, that's false. I was looking at the wrong side. So at 2 here's 2.5. At 2.5, the y value is 0, which is technically positive. Anything less than that, like 2.4, it starts off to be positive. At 2, it's positive. At 1, it's positive. At 0, it's positive. Even at -1 is positive. -2 is positive. -3 is positive. This is always true. So it has to be D. Okay, question 24. Uh, Consider the following formula: 2f minus g equals 0. Which of the following is true for this formula? This is a linear equation, but this one, I don't think it's recommended to graph it. What I would do is plug in values. So first, what I would do, we have 2f minus g equals 0. First, what I would do is get g by itself. Let's do that. So we're, how do I get g by itself? Just add g to both sides. You get g equals to that. So once we have that, let's test each value. So let's look at A. F is always greater than G. No, that's false. F is always greater because this is whatever F is, you're going to multiply it by 2. So that's actually the opposite. G, yeah, F is always greater than G. No, right? F is always greater than G. Um, what if F was 0? This would be, yeah, that's false. What about B? If F is positive, G is negative. So what if you did F equals 0? 0 is technically positive. So that would be G equals 2 times 0, just 0. No, that's a positive. 0 is technically positive. So that's not a strip. C. If F is positive, G is positive. F is positive. So we could plug in values. If F is positive, let's try 1. So this would be G equals 2 times 1, which is 2. What about 0? Zero is definitely positive, so don't forget zero because zero is positive. So it's g equals 2 times 0, 0 times 2 is 0. Zero is technically positive from so I think this is always going to be true. So I think it's going to be C. 25. Consider the following formula 5a equals b minus 15, which of the following is true. This one, I do believe this one we just have to graph it. There's no other way out. If you try plugging in these values, some of these might be partially true, so you can't, you just have to graph it. So what I'm going to do is a, get b by itself over, or get a by itself, sorry. So I'm going to divide everything by 5. So I get a equals 1/5 b, and then negative 15 divided by 5 is negative. Or no, actually, you can also, I think it's actually easier to get b by itself. So get b by itself. So I'm going to add 15 and add 15. That's much easier. So b equals to 5a plus 15. Okay. Now this is definitely a linear line. So my x is not really x, my x is really a. My y is not really y, my y is really b. Okay, then I'm going to find the y-intercept and the x-intercept. So the y-intercept is your b, which is 15. So my y-intercept is 15. And then my x-intercept is actually set y to 0 or b. And then you have 5a is 15. Solve for a, so we subtract 15 from both sides. We get negative 15 equals to 5a, this by 5. We get a equals negative 15 divided by 5 is negative. So you have an x-intercept at negative 0. Okay, go ahead and start that. So my x is not x, it's really, what is it? A. My y is really b. My x-intercept is 15, so maybe we should go by 5s. And then my x-intercept is negative 3. So if we're going by 5s, this is negative 5, 10. This would be negative 5. So negative 3 would be some of that. So on the x and y axis, we're going by 5s. So we have a point of negative 3 comma 0 and 0 comma 15. Connect the dots. This goes up. Wait, let's keep on going. Okay, let's look at the choices. When the value of a, so a's or x, is less than 3, less than 3. So here's 5, 3 is right here. B is positive. So that actually is kind of partially true. At 3, the b is positive. At 0, the b is 15. But when you get to smaller, beyond, lower than negative 5, so negative, I don't know, negative 6, the b is negative. So that's not always true. What about b? When the value of a is greater than negative 3, b is positive. And when the value of a is greater than negative 3, here's negative 3. So maybe if you try negative 2, the b's up. Is it always positive? I think so. Here's negative 2, the b's positive. At 0, it's 15. At 5, it's positive. At 10, it's positive. So it's always going to be positive. So this is always true. Point 6. It's 26. Here, another linear line. And they're asking which of the graph option represents the same relationship. So they want you to find the equation of this linear line. Well, which one is interesting? So what I would do is pick some points on this linear line. Okay. So I'm going to pick this point. But here that point, so we're going on by 2. So this would be 2.0. And I'm going to I'll pick this point. That point it would be at negative 2. 2. So what I would do is like find the equation. Right, find the equation. So let's put in like what I'm not supposed to be. Do we have the M? I don't think so. We have B. No. So this is not the B. This is not 2. This is an X set. So let's find the M. So to find the M, we're going to label this as M by y equals 2 by 2. Then I'm reading the formula M equals y2 minus y1 over x2. So my y2 is negative 2 plus this y over, so my y minus 0. And my x2 is negative 2 minus my x1 is 2. So negative 2 minus 0 is negative 2. Negative 2 minus 2 is 4. 2 minus become positive. This can be 2 squared. 2, so that's 1. And then find the b. My b is, so I'm going to put a little point. It doesn't matter. So I use this point. Y is going to be 0, and then x is going to be 2. So 1 half times 2 is 1 plus b. So 0, and it's after I'm subtract 1. You get b equals negative 1. And my equation is going to be 1 half x minus 1. So which one of these is related to that? Is it A? Um, X minus 2y equals 2. So they have it in standing form. Let's get it in y. Let's put it in where y, isolate y. So I would have to subtract x, get negative 2y equals to negative x. Right, oops, no, two. Negative 2y equals negative x plus 2. And then divide everything by negative 2. You get y equals positive x minus 1. Okay, that's exactly the same equation as ours, right? Y equals 1 half x minus 1. So this concludes that this is the one. Consider the following table, which contains the values that found on a graph of this function. So they can view a table with points. They want to know which one. Yeah, it looks we have a linear line for 2 minus 2. The function is definitely not linear. C, that's a linear line, and D. Uh, so let's look at D real quick. So it looks like
we can eliminate D. Why? Because if you look at our table, we have a point at 0.4. And then here, we don't have a point at 0.4. We have 0, 0, right? So we can eliminate D. It's not, I think that's a center. So we've got to figure out if this is linear or not. How do you know if it's linear? So so from look at so from 0 to 1, you had to have one. From 1 to 2, you had to have one. From 2 to 3, you had to have one. 3 to 4, you have to have one. 4 to 6, you have to have one. As long as these are constant. Now let's look at the y's. From 4 to 2, I think you have to subtract 2. From 2 to 0, you have to subtract 2. From 0 to 4, you have to add 4. That's a big indication that this is no longer linear. Difference has to be constant. So we can just say we know it's not linear anymore. Because yeah. So we can eliminate A, we can eliminate C because they're both linear. This is definitely not linear, so it has to be. Consider the graph following. We have y equals ax minus b, where a is 0. So I would just plug that in. A is 0, so it's 0x, and then make minus b. So you get y equals -5. And what that graph looks like is a horizontal line. There's -1, it goes completely horizontal like this. So it's not the first one because that's a vertical. It's not the second one. No. Yeah, 0, 1. That's not part of our graph, right? 0, 1 is not part of the graph. He said, there's one. Oh, yes, it's exactly this one. So it has to be 0.9. We have y equals 3x plus 1. Which of these four represents a relation plus? So it has to be a linear. Let's see. So is it A? The function graph line intercepts at the y-axis at 1, y at the point y equals 1, and with an x-axis at y-axis is negative. So what they're saying is, do this graph have an y-intercept at 0, 1? Yes, because the b is 1, that's only y-intercept. And then does this graph has an x-intercept at -1/3? So how do you find the x-intercept? You set y to 0 and solve for x. And we'll subtract 1, subtract 1, we get -3x divides by 3. Yes, that is double entry. So it has to be A. This one, consider b equals 2 and c equals 6. And we've got to simplify it. So if you look at all choices, they're all in terms of A. So let's just plug it back in. 630. So just be careful. So it's going to be A times B, just 2, times C, just 6, minus 4, parentheses, parentheses, plus C, which is 6, A, which is I have no idea, minus B, just 2, times A, I don't know what it is, plus 1. Okay, so here, do the inner parentheses first, so 6 minus 4 is 2, plus 6, and then this is 2. This one here, 2 times 2 is 4. And then let's explain this out. Let's roll this out. What's a minus 2 times a plus 1? Roll it out. It's going to be a squared plus a minus 2a minus 2. You get a squared. 1a minus 2a is another of a minus 2. Right? 1a minus 2 is negative 8. Or the 6 out, 6a squared minus 6a minus 12. And then this is going to be now 4a. Put it all together. You can so put it in order. So 6a squared, 4a minus 6a, and then 2a minus 12. So that looks like it's letter A. Okay, so all you gotta do is plug it in, be careful, FOIL it out, left right terms. Almost done. So we have C equals D over E and E equals FG over H. And if D equals 14, F is 4, G is 8, and H is 16, find C. So just plug it in very carefully. So C equals D, which is 14, over E, which is string, F of G, FG over H. And then F is 4, and my G is 8 all over H. We have a complex fraction, but it's okay, be careful. So 14, 8 times 4 is 32 over 16. 32 divided by 16 is 2, and then it's found out. It's actually not complex. It's 14 divided by 2 is 7. So that would be really deep. Wait, last one. I think this is the last one. Yes. If x1 minus ca equals to what is a? So they don't give us any substitution. We just got to isolate a. So x1 minus z equals we gotta find a. So first thing I'm gonna do is get rid of this x1 by subtracting x1 from both sides. And this is going to be negative z a equals to b x1. And then solve for a by dividing both sides by z, or everything by z. When you get a, you can ur, and that's x1 all over z. So I think that's going to be what we look at that. Ur x1 letter B. Okay, look, got it all done, and we got it all right. And then so we got nothing right. So if you want to play, then let's submit it. Oh, we have one right. Let me see what we got. Did I did I miss some? Oh, I didn't do 33. Sorry, let's do 33 real quick. Isolate the variable formula a b plus c equals d plus c, find b. So I don't I'm just gonna just solve for b. So I'm gonna first subtract c, Subtract C, this cancels, we're left with AB equals to D. And solve for B, so you divide this by A, divide this by A, get B equals to. Okay, so now we got it all right. Okay, I'm going to stop here. So this is IBEW practice exam test 3.